Welcome to the second KU, so the second practical stream. Today I'm just with Tanja.
Hi.
Yeah, you will see Michael next time again. So what do we want to do today? Well, first off, we have some organizational matters with the first assignment and so on. Then we'll have a quick recap about things you already saw in the lecture, so about data types and operators. We'll also show you some compiler warnings and errors you get when building your program. Then we'll recap structs, and all of this will be encapsulated in one large example, so you actually see some more code now in the practicals. So first off, the organizational matters, homework 1 and the coding session 1 is now open, so you can do homework 1. You can also do register for the coding sessions. Very important, the deadline for the first coding session registration ends before the first coding sessions are. So in 3 days, the registration deadline is already the registration deadline. So if you did not register for coding session 1, then please do so now, because in 3 days you can't.
And if you, for some reason, don't see any slots anymore, just let us know on Discord, because then we can just unlock some more slots for everybody. But so far, the slots haven't been filled.
Yeah, and maybe it's also smart to register early for a slot, because then, of course, there are more slots open, because not as many other students already registered, so you can find a time slot that really fits for you. Especially if you have some other some time where you can do your slots. Registering early is important. And that also means that homework 1 is now available. As with all coding sessions, you just have to hand in the homework before you attend your coding session slot. So the deadline completely depends on your slot. It's about Linux and Git, so what we did last time in the practicals. And don't forget that you have to do the reflection quiz after your time slot. We can see all this in the Teach Center. If we scroll down to the coding sessions, then we are currently at that the homework for coding session 1 and the registration is live, and then soon you can attend your coding session 1 time slot, and then afterwards do the reflection quiz. Are there any questions?
We've received a question with regard to if the homework of the coding session is related to the assignments or something else. So the coding session is separate from the assignments, but of course the topics that will be that you'll be going through there are still important for you and for the grand scheme of the practicals, but they're not directly related to the assignment. So as we've said, the topic for this one is going to be Linux and Git, which will be important for you for technically all further assignments, but there's no direct correlation to the assignments.
Yeah, but in general, the coding sessions exist so that you have an easier time doing the assignments. Okay, then let's continue with assignment 1. As you probably know, it will be released today. All the information you need on what the assignment is and how you can get your repository will be announced on Discord after the lecture. There's also an introduction video that explains everything about the assignment that is available today after the lecture, and the deadline is on the 29th of October. So in 2 weeks on the Wednesday. And 2 more things, some very important tips for the assignment. The first thing is read through the assessment of assignments. So if you're in the Teach Center, you can go to our course website, and then if you scroll down to the practicals part, we have here the assessment of assignments. And it is important that you actually have an overview of what's in there. If you don't need to remember all of this to start coding your assignment, but just have an overview about how we grade your assignment. So you don't do any, do in your whole assignment something that you have to fix afterward because you find out that you will get deductions for this. And if you don't follow this, you also will get deductions for the assignment. But after the first or second assignment, I think the assessment of assignment yeah, you really get to know it very fast. Yeah, and the last thing for assignment 1 is please start early, especially try pushing to your GitLab repository well before the deadline. So I'll just say now, try pushing to your GitLab repository at least a week before the deadline, because if there are some errors and maybe you need us so that we can help you with your repository, maybe there were also some issues creating your repository. If anything of this happens, then if you do it on the last day of the deadline, we might not be able to help you because maybe none of the tutors have time right now. So really try pushing to GitLab at least 1 week before the deadline. This would be also very beneficial for you.
This is especially important if you registered for the practicals late, because the registration in the Teach Center in TU Graz Online is still open for a few days, I think. But we're going to create the repositories tomorrow. So that means if you've signed up like today or maybe like in the next couple of days for the practicals and you see this in hindsight, that means that you may not even have a repository. And if you notice that on the day of the deadline, that will be a bit inconvenient for you, of course. So just make sure you have a repository and that you can push to it, so you can ask well in advance on Discord if you need any technical support or something like that.
Yeah, the best thing, if you, the day after tomorrow, you can look into GitLab, you'll have your repository and just push some, your MTC file or write some main there and see if it works, so you don't get any trouble later on. Okay, so this was very much about the assignment 1. Watch the introduction video, everything should be explained there, but now let's continue with the actual practicals.
Right, so we're going to start off by recapping data types, which we've already heard about in the lecture last week. So we've discussed some different data types. We've had integers, wrong one. We've had integers, we've had chars, we've had floats, doubles, all of those things. And basically what we just want to recap one more time is that data types give data meaning. So it's really important that you choose the right data type for the variable, like for the context that you need it in, because for example, if we have something like integer x equals 65, this could be like a variable in some equation you're doing in your program, but then we could also have an integer called age, which is 65, which in terms of data type itself, that is still just an integer, but in the context of the program, that already means something very different, because the age is probably the age of a person or something like that. But we could also have something like char exam grade equals an uppercase A, which, as we've also heard last week, an uppercase A, or characters in general, can also be integers in the background if you look at the ASCII table. So technically, if you look at it from an integer point of view, the uppercase letter A is also 65, so the number is 65.
Yeah. So with these examples, we can really see that both the variable name and the data type are very important, because with the variable name, it just helps to give you context, because if it's just exam grade and you don't know the data type and it's some data representing 65, then yeah, you could get confused pretty easily. So it's important to name your variables something sensible.
Exactly, and this becomes especially important when your programs become more complex, because if you can't even see like the initialization of a variable anymore because you're so far down in your code, then yeah, it will be hard to trace back what that was supposed to be and how you wanted to use it initially. Right, so what are we going to do today? Well, we're going to use a few different data types. Well, today we will do a little example. We will write a distance calculator for 2 points in a 2D plane. Nothing really fancy. How are we going to do that? What is the program supposed to do? We will read in points for user input. So just x and y values. You've already seen this in school. And we're going to calculate the distance and midpoint between them. So like if we have a point here and a point here, we have a point in the middle right here, and we have a distance between them. And we will also visualize the length of this distance with conditions, loops, and prints. But we'll get to that now. Yeah. There's also a little graphic.
I hope all of you already have an idea on how you could calculate this distance and the midpoint.
Should have been a topic in school, but we do also have we're gonna have the variable and the formula also in the code, right? So again, we have a point 1 with an x and y value. We have a point 2 with also an x and y value, and we want to calculate how long this distance is between them and the midpoint in the middle between. Right, so that means I will switch to the VM right here. And we will start coding real quick. So first, we've already prepared our little program here. Ignore these for now. So what we first want to do, we don't have the return 0 in here. So what we first want to do is that we want to read in some user input. So we first need to tell the user what we actually want to see here. So we can do that by first printing our input prompt, so to say, by just saying point 1. And then we're just going to say enter xy. Like that. And then we can use scanf, which, if you remember, is a function which we can use to read an input from the standard input. And here we will for now say that we want 2 integers, which is why we use %d, and we leave a space and we use %d, so we can use this format that we specified up here. Then we of course need variables to save this in. Sorry.
No, I don't know if they did this in the lecture, but if you type %d space %d in the scanf, then it just expects 2 numbers separated by a space.
Exactly. So this is just basically the type of assortment of characters that it's going to ask for.
So it just does what you would expect.
And we also need, of course, some variables to save whatever we want to read in here. So we have our integer .1x. We're just going to set that to 0. We're just going to use integers for now because that should work for our first version of this. And then we can just real quick, because it's going to look the exact same for point 2. So that's how we have 2 points. And then here, we now need to specify where we want the values that we read in here with the scanf, where we want to save those to. So for that, we need to specify first, since we're entering point 1 here, we need to specify the point 1x and the point 1y. And we can do this by using the AND symbol right here, and then just typing in our variables. So we can tell our scanf, hey, so the AND in this case, you don't really have to very carefully understand this yet. This is going to get more important later, but all we have to remember for now is that this tells us, okay, please save this at the location in the code where we have put this. So it's basically telling the scanf, please save that up here. Yeah, just in this variable.
Basically, you've heard about memory in the lecture, so .1x is a variable with some memory, and we just tell scanf here, okay, save this integer to the memory where this variable is stored.
Exactly, so we can then do this again just for our second point. Going to look the same, except for the fact that we now want point 2, and we also want point 2 here and point 2 here. Yeah, and then let's do, just to wrap it up with a neat little bow, let's do a little print that tells us what the points are. So we have point 1, and we're going to give it a nice structure like we usually use it in math. Once again, we have integers up here, so we're going to use %d as a format specifier in the printf. And then we do point 2. %d. And then we will name all of our variables. So we have point 1x as the first one, point 1y as the second one, point 2x as the third, and point 2y as the fourth.
Yeah. So important with printf, you don't need these and symbols here. So you can sort of imagine like, okay, scanf writes to those variables, so we need the and printf only reads from those, so we don't need it. How exactly this works, you'll see later. There was a good question in the chat. Do we need the equal 0 up here when we create the variables if we directly after do the scanf?
Technically, no, since you're not using the variable, but it's always important to initialize your variables in some way, shape, or form, because if you just say like point x here and you immediately use this variable, this just gets stored somewhere in memory, but you actually haven't defined like what is at that point in memory. So there could be some garbage here, you don't know. So if you immediately use it, it's just going to lead to errors. And this will be important in the assignment, so please do remember to always initialize your stuff. Even if it seems unnecessary, just do it. It really doesn't hurt.
Yeah, I mean, in this case, it's really unnecessary because we overwrite it in the best case directly afterwards. But as your program gets more complex, you at some point might think, okay, I don't need to initialize it here, but then don't write to it and then access the value there, and then already there are you get some really weird problems that are very hard to figure out what's exactly wrong. So my recommendation is just do it because it helps prevent you some bugs.
Yeah, perfect. So that is our code for now. So now let's try to run our program for the first time in the state that it's in at the moment. So we haven't shown this last week, so we're going to show it now. If you're in Visual Studio Code, you have this tab up here called Terminal. Then you can just select New Terminal, and that's how you can also just open a command line directly in Visual Studio Code. So in here, we can once again just use clang, and we do -o. Our program is called main.c, so let's call our executable main, and we are compiling main.c. And then we do /main, so it's going to ask us, oh, 0.1, and we enter 1, 2, enter 3, 4, and it will print 0.1, 0.2. Now you can see here that this is a little bit ugly if we already have the prompt for the command line in the same line as our output print. You can also in printf and generally in prints and anything that's a string like this, you can enter a new line manually if you do a / and an n. You add that. So if we now just compile our program again, we can see one more time. Now it looks nicer. Now we have a new line in here, and it actually broke to the next line. Right. Okay, then let's get to the next point. Let's talk about compiler warnings and errors now, because this is another important point for the assignments. So what are compiler warnings and errors? Basically, the compiler, if you give him the right tools, he can detect syntax or general errors in your code. If these errors prevent compilation, so in the sense that the executable file can't be created because of a mistake you have in the code, then that's a compiler error. But if the compiler just thinks some piece of code is suspicious in a way, so it kind of looks like it would be wrong, or it doesn't look like it's used correctly.
Or it's just unusual, so the code looks like maybe it does something you didn't intend to do. So the code is correct, but maybe it does something different than you think.
Exactly. So, and if it's just suspicious, it turns into a compiler warning. So how can we use compiler warnings? Because the errors will happen no matter what if you make a mistake in your code, but the warnings actually only happen if you use compiler flags for them. So we've already seen the -o in the compiler command for specifying the name of the executable. We actually have a few more flags that we can use for warnings. We have -wall, which stands for all warnings, but it's not actually all warnings. It's just the most common warnings. Then we have wextra, which contains, which activates some more important warnings that aren't yet in the first flag. And we also have -pedantic, which includes warnings related to C standard violations. So these are more like cosmetic things you could say that just aren't good code practice, I would argue. Right. Something that's also important is that there are different versions or revisions of the C language. So even though it's a programming language which we write programs in, someone also had to write the programming language, and the programming language could also receive new functionalities or could contain bugs that are fixed. And if a lot of these things happen, then maybe we release a new standard. So basically you can compile for a certain C standard as well. So you can say, okay, I'm using the C version this and that, which contain these and these things. This is important because in ISP we're using C17. I think there is already C23 out there, and there's a lot of older ones, but yeah, we're using C17, so we can include that by just doing minus standard equals C17, which is the compiler flag here. Yeah, so that was a lot of flags all put together. This is going to look like this. So we again have the clang, the minus W all, minus W extra, pedantic, standard, naming, and main.c. Right, so let's show that real quick. So let's introduce some, let's say I forgot the point here. Start this way. So we haven't added any warnings yet, right? So now we're just going to try to compile the program again, and we'll get the error. Oh, expected a semicolon at the end of the declaration. It's going to tell you the line as well, line 5. This is the line right here. And it's going to tell you, hey, this is missing. Please add it. So we cannot compile unless we fix all the errors that we have. Now we don't have any errors, so now we can try compiling with all of our extra flags. And we do minus pedantic. 17. And we do enter. And we didn't get any warnings. That's great. Now we could also introduce some warnings. If we do something like, we just remove that here, if we just remove that here. Should just be warnings, I think. Yeah. So here we have 2 warnings. A function declaration without a prototype is deprecated in all versions of C. So here we see the void that we've added here all the time is actually a warning in C17. And we can also see that the compiler is warning us, hey, something's wrong here. You have like this integer, what the star means you'll learn in a little bit, but basically it thinks it's a
different data type.
Yeah, exactly. It's a different data type because we haven't added the and symbol here. So it doesn't know that it has to look at that address.
Yeah, so within these warnings, there are a lot of words you probably do not understand now, like prototype, functions, or what this integer with a star is, but you will learn all of this in this course, and at the end, hopefully, you can understand those also a bit better.
Yeah, the most important thing is that if you get warnings, please fix them. Because, I mean, the void here, I think, wouldn't actually make a difference, but this would make a huge difference, actually, if we forget the and symbol here. Then we just wouldn't save it correctly.
It would make a difference in the grading of your assignment because all warnings are a 25% point deduction. It's just because they are so easy to avoid, and just fix them if you have them. They're never hard to fix. If you are somehow stuck with a warning and you don't know how to fix this warning, just ask on the Discord. Important, don't post any code on Discord, just a warning, and we will certainly help you. But in general, these warnings are really easy to fix because they tell you what you need to fix. So there should be no reason why you get a point deduction. Therefore, always compile with those flags, and also look on GitLab, but you will see all of this in the intro video.
So we've now seen that when we do not add the void in the brackets of the main, that we get a warning for that. And this is important if you're not working in the VM. If you work in a different environment, please make sure that you also cross-check with the VM if you get any warnings, because we also have a little example here if we're right in VSL. So this is not the VM anymore. We're working in VSL right here, which is also an environment that you can code in. And here,
we forgot the void in the main.
we do not have the void here. So now we can, did you already? No, okay.
Yeah, I think you should type 2 up.
If I type 2 up, then we have the command already.
Yeah.
Ah, there. Okay, so here we have once again, and here we can actually already see with these flags, you can just put them anywhere. Because as you saw before, I put them in front of the naming and the main.c. You can put these anywhere.
Yeah.
It's still gonna work. So if we do this here, do mind, we do not have the void here. We should receive a warning if we compile it this way. So we've compiled our program, we do execute the main. And as you can see, I mean, actually executing the main wasn't necessary, but basically we should have received a warning right here about the void. But we did not receive this warning because in this VSL environment, we actually have a different version of the CLang compiler. And that can make a difference if you don't have the same version of the compiler or just a different compiler than the VM has. So please make sure that you check your submission with the compiler that runs in the VM, because that's also the environment we tested.
And the warnings will also be displayed on GitLab. So if you push your code to GitLab, you can then online on GitLab also see the warnings you got where it is ran in our environment. So you don't, if you do not use the VM, you do not necessarily need this. You can also just check on GitLab if there are any warnings. But it is important to check because as you see here, leaving out the void here in the main does not produce a warning outside of the virtual machine. But if you go back into the virtual machine,
wrong one.
Then leave out the void, then you can see then it's a warning. And this would be a 25% point deduction. So yeah.
Exactly. Right, I think that's everything that I wanted to show.
We have Clang 18 in the virtual machine.
Right, we can just show that real quick as well. How you can check that, if you do Clang -- version, you can see the version right here.
Yeah, so if you install Clang locally, try to use that version because this is the closest one that you will have to our virtual machine. But there can still be differences. We can't guarantee that there are no differences, therefore always check online.
Exactly. That's right.
Yeah, the next thing I want to show you, pretend that in here, maybe I'll make this a bit smaller, we do not have this print statement yet. Maybe we are in some complex program, but I still want to see, okay, what are the values of my variables? And I do not want to go in there and everywhere I want to see what values do my variables have. I do not want to insert a printf because maybe I have some weird issues and I need to really figure out what's going on. Then just inserting printf often is not a very tedious solution to figuring out what your program actually does. What we can do here is use the debugger. And I have a slide here on how to set up the debugger. First, you need the extension code LLDB. It's already pre-installed in the virtual machine. So if you use the virtual machine, you do not need to do anything else. In VS Code here with extensions, search for code LLDB and install this here. Okay, next. You need to select run and debug and then select LLDB. So let's do this. This is here, run and debug. Then run and debug here, this button. And here we want to select code LLDB. Do we have some errors in the virtual machine now?
That's new.
Maybe if I just try again. Oh, okay, now it works. So this error you get here, the other one, I don't know, but this error here is expected. Maybe I have it on the slides. Yeah, but this is the fix for what you get. You need to open the launch.json and set the name of the executable. So if you get this here, then you need to open here, create a launch. No. Or maybe it does not work in the VM right now. I don't know why.
It worked with the top one.
Maybe I just show it outside of the VM. I hope that it works for you in the virtual machine, because I did that test this last year and it did work. Maybe try it here outside. You select no code LLDB. So again, run and debug. You select code LLDB, and okay, apparently it's the same error.
Did they change something about the extension?
Yeah, maybe let's try the top one. If this works.
That looks good.
Yeah,
yeah,
okay, this
go.
works. Yeah, so maybe we need to adjust this afterwards in the virtual machine, because we'll write on Discord. If you have the same issue, I'll figure it out and write you a fix on Discord. Yeah, if you click on run and debug here and choose the top one, it apparently works. I'll write a fix for the code LLDB1. What we can see here is that we have this bar up here where we can control the program. And what we can do now, before we start it, we can click here to stop, is we can place here a breakpoint. And if you run it with the debugger, your program will stop before this point, and you can inspect the state of your program. And this is really useful. But what we need to do, this is another flag. You need the -G flag to compile with some debug symbols that the debugger needs to actually figure out where line 10 is in your compiled code. So if you want to use a debugger, write -G here. Then run and debug. And as you can see, the scanf did not appear yet, and also not the printf, because our program stopped at this highlighted line. And you can also inspect here all of the local variables that we have, and we can see we set all of them to 0. Then, if we click here, we can step over a line. That means we go to the next line. Right now the printf should be executed. We do not see it yet. We need to step once more. Now we see it, but we also see that our program is not currently stopped. This is because we did not hit this breakpoint yet, because we first need to enter something in the terminal. Our program is currently running, so let's enter something, and then we can see, okay, we hit the next breakpoint. Maybe I also place one down here. I can click on this one to continue running the program. It will ask me for the second point, and we hit this breakpoint here, and we can see, okay, before doing the printf, we can already see that the variables in the points are the correct ones. So for point 1, 2, and 5, and for point 2, 1, and 3. Yeah, so I hope the debugger works for you. I'll look more closely at this at home then. Yeah, this is everything I explained right now. I also put it on the slide so you can look at it afterwards. Yeah, so the next thing I want to do, I want to recap what you learned about operators. So operators also, as the name implies, they operate on data, but they also need context, because they have to do something different. So if you think about the plus operator, where you add two numbers, it needs to do something different if you add two doubles or an integer or an integer. So data types are important when you use operators. Some examples. You need to think of this while programming, because else you could introduce some errors. I think you already had this in the lecture, but just to recap, If you add two integers, you get another integer. So 1 plus 2, now x, the integer has the value 3, because you added two integers. If you add two double, you get another double. I think this is pretty clear now, but maybe what's more interesting is what happens if you, for example, add an integer and a float. Well, then it promotes the data type that has less precision. So here the integer, because there are no points after the decimal, to a float, and then produces a new float. So this also works here. If we add 1 and 2 as a float, then you get a new value which is also a float.
And we add the 0.0f at the end to really define that it's a float. And because if we just write 2, it would be an integer again, and the 0.0f turns it into a float.
Yeah, but if you can also just write 0.0, then you use a double. Generally, I think in this assignment you should always use doubles instead of floats. Okay. So I want to implement the first thing now, namely the midpoint. How does this work? Well, we just add both coordinates and divide it by 2. So sort of like the average of the coordinates. So it's just a point in the middle. So I'll just stick to the naming convention, and we'll do what's up here. So we'll take the 0.1x, this one here, add it to the point, here we have x2, this is the 0.2x, divided by 2, and we do the same for the y coordinates. So we have 0.2x plus 0.2y and divided by 2. Okay, now we also want to print this. So something like midway point yes, and then I do the same. I don't know the keyboard layout. How do I do the
wait, this one?
Yeah, this one. And right now I did two integers, so I'll also print them out as integers. And then mid and midpoint y. Okay, so now we have this here. Let's try it out. I'll compile it. I'll use the arrow up key to just get back to the compile command. And then I'll execute it again. So we'll enter x and y here, 1, 1, and maybe 2, 2. What we would expect here is that the midway point is at 1.5, 1.5, right?
Mm-hmm.
But what we get here is, right. Additionally, I did this wrong here. But what we get here is something unexpected. Maybe I do it with the correct code. Here I had an x, but of course we want to add the y coordinates. Yeah, so for some reason here I did... Yeah.
No, it's you're using 0.2y twice. We need 0.1y there.
Okay.
This is a great lead-in into what we're going to do after this.
Yeah, okay.
Okay.
Now, at least we get the same two things here. And as you already expected, we do not have something with some value after the decimal point, because the midpoints are already integers, and you already had this in the lecture. But what exactly happens here? Well, an integer divided by an integer produces an integer, and therefore 5, for example, here 5 divided by 2, it would be 2.5, but we get a 2 because it is always rounded down with the integers. But luckily there is a fix. If we divide the integer by a float, then we actually get the float as a return value, which is also what is expected. Yeah, but how can we fix this? Of course, I mean, I could make 0.1x a float now. Then a float plus an integer is a float. A float divided by an integer is also again a float. So we would get a float here, then I also do this as a float, and we would get the correct answer. But I want to keep, I have all these points already as integers, and I want to keep this. So what is the solution now?
The solution to that is typecasting. So basically what typecasting does is that we can change the data type of a value kind of on the fly, you could say. We can do this two ways. We can do it implicitly or explicitly. Implicitly would be if we have an integer x here, that is 5, and we then say that the float y gets the value of x, then technically we've turned the 5 into a float, right? Because we're now saving it in the data type float. Same, but a bit in the other direction would be if we have a float y, that is 5.75, and we then save this value in an integer, then of course we would cut off the 0.75 back here, and we're left with just the value 5. If we do it explicitly, that means that if we have, we use these brackets with the data type within them in front of the value. So we have this integer x here that has the value 5. And then we can do, okay, our double y will be a double now, and we just add this so that the x turns into a double. So this is like the explicit way of saying, okay, I want to change this into a different data type. So this is...
Yeah, and then you also would need to create a new variable. Yeah.
Exactly. So you could also just do this without saving this in a new variable. So you can really just change it on the fly this way. So if we go back to the VM, we can now make a few changes to our code to turn this into double. So we can already say, okay, we want to save a double in the first place, but we still have the problem that back here we have all integers. So in the end, we would still receive an integer. So that means back here, we also need to change one value to a double. We can do this two ways. So we can just define the 2 back here as a double by adding 0.0 at the end. You also saw that in the slides. We can actually also see it when we hover over the number. So if you hover over the 2 now, you see there's an int before it. And if we now add the 0.0 at the end, it will say double. So this is also how you can do it if you have an explicit number somewhere. Or we, for example, just add in front of our 0.1y, we just add the double here. And now we have casted 0.1y, our integer, to a double on the fly.
Yeah, and if you just play through everything like we did in the slides before, then you have a double plus an integer, so we get a double, and then a double divided by an integer is also a double.
There's one additional thing we have to change in this case though, because here we're still printing integers. So we would also have to adjust any printfs that we're doing with these variables because we've changed the data types. So instead of %d for float, we use %f, but now we have a double. So we use LF, which probably just stands for long float. Right. So now we can try this again. Wait, I think I didn't save. Saving is important. So now we again do 1, 1. And now we have our 1.5 with a couple zeros at the end, but we're fine with this. So now we fixed our issue. Add in the code. All right. This is also an important point which may not be that relevant right now. This is more relevant when you get to like bitwise operations, which will come in the lecture later on. If you change the data type with a cast, the binary representation may change. So we were working with the decimal system here, right? So 1 through 10 and all that, but there's different representations. We also have the binary representation. And if I have a data type that has a different, if I'm casting something that's a smaller data type to, for example, like a bigger data type or an even smaller data type, that does influence the binary representation. So if you do casts and you also do bitwise operations on the number, that you need to be aware of that. Not so relevant right now, but do remember for the future.
Yeah. Before we move on, I still owe you the distance.
Oh, right.
So, yeah, we already saw. So how does this work? Well, we just use the Pythagorean theorem, where we just calculate the length of the sides of the triangle, and then using here we can do the square root and then figure out what the actual distance is. So I'll do something like this: integer a for side A, which is 0.2x minus, I press caps lock, 0.1x. So because here 0.2, 0.1. And I'll do it as an integer because it does not matter up until now. Even if we do want the exact result in a double, this is an integer, this is an integer. If we subtract them, the result can only be an integer. And yeah, also if you would cast this to a double, the result still would be, it would be a double now, but there wouldn't be any digits after the decimal place, which are not 0, because, yeah, think about it. I think you can figure this out why this is. Then we'll do the same with y, 0.2y minus 0.1y. So this is this here. And what we do now is, I want to double the distance, because the distance now might not be an integer, so I want to store this as a double. And what we will do here is we'll use the square root. The square root function, yeah, this is already built in into C. You can use this. This just does the square root. We need this because we have here this squared. How do we do squared? There are some functions for this, but I think it's the easiest thing to do now is just use do it something like this.
Yeah.
To do the squared thing.
So we don't have to explain more, but there is also its own math function for doing like x to the power of 5 or something. So this is not just a to the power of 2 and b to the power of 2 if you put it in English.
Maybe one more tricky question. So a and b are integers. We multiply integers here, and then add integers. So this whole expression here is an integer. And then we do a square root and save it into a double. Now, will this have, will this be rounded down, or will this be an actual double value? Yeah, I think we need to include.
This is also a good practice already, because, oh, we used a function, but this function that we have here is not included in the includes that we added at the top. So we need to add that at the top as well.
We already see here, node include header math.h, and we'll do this.
Let me just do that real quick.
Yeah, and back to my question. So is this now, are we rounded down when we pass here an integer into the square root function? Well, maybe I just revealed it because I hovered over it. Yeah, maybe this is also important. If you use this math.h library, when compiling, you need -lm to get the math library. Okay, but now we have. So 1, 1, 2, 2 again. And we can see, yes, this is the correct distance. and this is just if you hover over the square root function, you can see it expects a double here. So this integer, when you pass in an integer here, it's promoted to a double, and then the square root calculation is done on a double. Yeah, so I think we have the distance calculation down.
This should bring us
No, this was the wrong one.
This should bring us to the last part of our program. Oh, right, versus structs, right?
Yeah. So first thing we want to do, I already saw it in the chat, very good intuition. Of course, these points are a prime example for structs. That's why we chose them, because you might have already noticed that it is pretty cumbersome to have these 4 variables here, where we have 0.1x, 0.1y, when somehow we know that both x and y of 0.1 belong together.
And it's really easy to make a typo because they look really similar. There's only 2 characters difference, and if you're coding quickly, I
already did the typo.
Show by example.
So, yeah, what do structs do? Well, they group data types into one. So we can group 2 integers, an x and an y, into 1 point, and then we have a new data type. Back to the live coding. So how do we do this? I think you already saw type def. I'll directly use this because it's just way more convenient to do it like this. You of course need the struct. By our style guide, you need these underlines here. No. Then we'll want an integer in our point. So here we just write what variables do we want to group together. No, I want a y. And then I do it like this. What this type def here does, it is just says, okay, the name we have here, point, is now defined to be this type. So the struct with an x and a y. And maybe let's already replace the first point. What we can do now is point, I'll call it 0.1 equals, we want to initialize it because we learned we always want to initialize it, but what do we actually write here? Because we can't just write some 0 here because this is an integer. It even tells us this is an error because int cannot be used to initialize point. We can already understand this error because this is an integer, but we have a point here. It does not make sense to assign this integer to the point. Luckily, there's also something we can use to do this, namely an initializer list, where we can initialize the struct members directly when creating a new variable of that struct. Here it is important that the order matters. So if the x is the first thing you do in the struct, you also need to specify it first. How does this work? Instead of writing 0, we can do this here and then initialize both integers in here. So now we can see there's no error, at least up here anymore, because initializing it like this works. Another thing we can do is, if we want to be explicit what we initialize, we need the underscore. We can also do it like this, and then the order does not matter. So when we do it like this, we could also initialize the y first. Maybe doing it like this is better because then you are sure what values you assign to what members of the struct. And because if you have more than 2 integers here, just listing all of the initialization stuff here can get very confusing. Then providing the names here like this is very convenient. I have some more questions because there was some confusion about how these structs work last time. My first question to you is, what is the difference if I do it like this now between point, so with a small p, and point with a big P. For some, this might seem obvious, but it is a very important distinction. Maybe I give you some seconds. Yeah, already two good comments. So point with the big P is the data type, like an integer, and small point is the name of the variable. And it is important not to confuse them. Now, how would I create multiple points? So if I want to create in here now the second point, my question basically is, do I need to copy this and create a second struct? So I create a second point here. Yeah, we have the first no, so no, you don't need this. Yeah, this might seem very obvious if you already understood the concept of structs. And yes, of course, you can create multiple variables from the same struct. Just as you don't need multiple, you just need the data type integer once and then can create multiple integers. Therefore, you also only need one point struct and can create multiple points.
Yeah, you can think of the type def struct at the top basically like a blueprint for a data type. You don't need multiple blueprints to build like 5 houses, for example. You just need one and you use that one multiple times.
Yeah. So now let's start fixing things here.
Mm-hmm. In the meantime, maybe it's also important to mention that structs will also be part of the assignment. So one of the parts of assignment 1 is actually to use a struct. So make sure that if this isn't really clear to you yet, because of course we're going quite fast here, just try to play around with them after the lecture, watch the assignment video and just try things out. Structs are really important and will also come again if in, let's say, later courses when we move towards object orientation. Structs are a very vital concept there. So the earlier you understand it, the better.
Yeah. And so, of course, you had this in the lecture. You access these members with a dot here, and then you can just use it exactly the same as you would use these x and y variables before. You can just use the dot to access point1.x. So we get the x variable of the point, and point1.y to get the y variable of this point. And to quickly fix this, I'll just replace all of those variables.
And even if in our program it doesn't necessarily look shorter to use the struct as opposed to the variables except for the initialization at the top.
Oh, sorry, I zoomed out.
Oh, wait, okay. Even if it doesn't really look that much shorter, especially as programs get longer, as you have multiple like custom data types and all that, it's really nice to just have fixed like variables that you always want grouped together under a concept, like a point with its 2 coordinates, to have a separate struct for that.
No, yeah, this was point 2, right? X, Y. I think the time is already pretty late, so I won't do this now, but of course the midway point here is also a point, so you could replace midway point x and midway point y with another point as a variable of this struct. Then of course this would be integers and would be rounded down, but let's ignore this. This would be something if you want to do something at home, you could try and change this midway point x and midway point y here, create a new midway point, just create a midpoint as a variable of the struct, and then you could also try changing the struct to use doubles. so you get the correct midway point here. So this would be something you could do at home to practice with these structs a bit more. Of course, creating your own structs would also be something that you want to practice. I think I replaced everything. Let's try it out. And yeah, this looks the same as before. So, but it looks way cleaner because we do not have 4 variables. We just have 2 instead of 4 variables, and especially in bigger programs, this would be important.
All right, that means we get to the last part of our program, which is that as we mentioned at the start, we have the distance calculated now, and we also want to visualize our distance in the terminal with some conditions and loops and some printing. So how can we do that? So we know we have a distance value, which we have right here, which tells us how long our line is basically. So we've already heard about conditions and loops in the lecture as well. So I'm just going to assume that you know what a while loop is, but we're going to recap it one more time here. So we can do a loop, which is called while, and we can put a condition here in the brackets, and then we can define some code within the curly brackets here. And as long as the condition up here holds true for the program, we will just keep executing code that is down here. So let's do while our distance is bigger than 0, so we're going to use a double here. We could also technically, because we don't have like a nice value here, we have 1.4, we can just say, okay, we're going to use a double here again for the comparison, because otherwise the compiler is going to complain. Or we could also technically just cast this to an integer and use 0 back here. That really doesn't matter. It just matters in the sense, do we round down or do we keep the value as is and go like print like 1 additional point? Yeah. So what we want to do now is we want to introduce an if condition here. We remember if was also like a way to branch between different cases for a code. So we have the if keyword, we add a condition here, and we once again have our code in our curly brackets down here. And if whatever is in here holds true at the moment where this is executed, then we will execute the code down here once, which is also the different. This is a while loop. This is an if condition, big difference. What we can also do with if is we can add an else. Else would mean, okay, if whatever is up here does not hold true, we will no matter what go into whatever we have in these in these curly brackets. What we can also do is we can make an else if. So we also add in condition here, so we can chain these together if we have multiple cases that we just want to check. Something that's also important here is that if we have something like this with if and else if, we're only going to enter one of these 2 branches. So if we enter the top one, there's no way we're going to enter the bottom one because they're chained together, because it's if and else if. If we were to do 2 ifs right after each other, we could technically go into both of these if both of their conditions hold true. Great. So now what we want to do is we want to do some condition, and when this condition holds true, we want to print different characters. So we have a nice little line with pluses and minuses. So if the top one holds true, we print a plus. And if the bottom one holds true, we print a minus symbol, right? So now we still need to think how we can distinguish if we want to have like a plus and then a minus and then a plus and then a minus, and we don't know how long our line is going to be, how we can differentiate between these 2. And there's this nice little operator that you've also seen in the weekly exercise already, which is called the modulo operator. So, wrong one. So the modulo operator is basically if we use the % sign that so far we've only used in scanf and printf, if we use that kind of like a plus or a minus between 2 numbers, in this case integers. So the concept behind the modulo operator is that it returns the remainder of a division between two numbers. In German, we call this Rest. So if you divide something and it's not a clean division, so if we divide like 6 by 2, the result is 3 and we have 0 remainder or 0 rest. But if we divide 5 by 2, then the result is 2 and we have a remainder of 1 because we can do 2 plus 2, that is 4. But we can't fit another 2 in there to reach the 5, so the remainder is 1. I hope that makes sense. That was probably a bit quick.
Yeah, but I think it should be clear what the remainder is here. So you just know that with the modulo operator, instead of getting the result of the division, you just get the remainder.
So why is this important now? Because we can, if we do modulo 2, what this expression can return is a 0 or a 1. Because if it would return a 2, then it still fits in the division. So this is a very easy way how we can chain like these back-to-back differences to each other. If we just use if distance modulo 2 equals, let's start with 0, then we print the plus.
Yeah.
And here it wants the integer, right? So technically you could use anything up here, but for modulo you need integer. Oop. Let me do this with the int cast. Right, and then down here we can do distance modulo 2 equals 1. Then we get printf here.
Yeah, you wrote the int cast in the wrong
All right,
line.
that's
yeah.
Oops. There we go. So we're just going to cast it here every single line. And then, yeah, that should be it. Definitely no more errors in this. Let's see what happens.
It compiled, so it must be correct.
It must be correct. There's no way this is not going to work, of course. Definitely not a spoiler.
Maybe add something bigger now, so we actually have some distance.
So let's do 4. Ah, well, that looks wrong. What's happening here? I do not understand. Well, does anyone in the chat have an idea what could be going wrong here? Why did we get a million pluses and nothing else? Ah, right, wait, we already have it there.
Yeah,
isn't it gonna run forever since the distance never changes? Exactly, very well observed, because our condition with the distance up here is never going to become false, because we've like put it on a value that can't change because we haven't actually told it to change in the context of this loop. So what we still need to add here is we need to add distance minus minus, which just reduces it by 1. You could also write distance equals distance minus 1. Doesn't make a difference. So if we now try to run the program again, we will see that it now works. Right, so now we have, oh right, we can make it a little bit nicer. We can also like do another printf down here with
outside of the while.
All right,
yeah,
whoopsie. Right.
Yeah.
So now we have our distance 4, and since we used integer up here for the while condition, so we cast this now, we now have 4 symbols here because we rounded this down, and we have achieved a nice little visualization of the line.
Yeah, but we also saw that with this while loop, this is pretty easy to mess up, and as far as I can remember from the lecture, there's something nicer we can use if we already know how long we want to iterate.
Which is a for loop. And the for loop works a little bit different from the while loop that we see here. We once again have our keyword for here, but then we actually set ourselves a variable that only exists within the context of the loop, which we can use instead of actually modifying our distance the entire time. Because maybe we also want to use this distance afterwards, and here we're actively reducing it, so we're basically like losing the variable in a way. So what we can do here is we can say for, then we say integer, we call it count distance or something, equals our distance again that we just had. Then we do a semicolon, and then we say that count distance instead of the distance that we had must be, whoops, bigger than 0. And as long as that is the case, we want to reduce count distance. Right. So then we can also remove this here because we don't need that anymore.
Yeah, and the count distance in the if. Right?
The count distance in the if.
In the if.
Oh, right, yeah.
Yeah.
So, we'll see. Right. So now we can just try that again. Basically, the functionality shouldn't have changed. Yeah, so it's still correct. The only thing that we did is that we don't need to keep track. We don't need to actively reduce our distance variable. We can also preserve the value that we saved up here. And we're just using this count distance helper variable, so to say, that we have because we're using a for loop to actually print the distance.
Yeah. Maybe just so we can go over this one more time. If what the for loop does is when the program is somehow executes this printf, comes down here, and then it creates count distance and sets it to distance. Then we check, is the count distance greater than 0? Our distance was 4, so it is greater than 0. So we execute this for loop body. We check, is it even or odd, print the correct sign, and then at the end, when we're down here and the for loop loops, basically, before checking the condition again, like a while loop, this is executed. So we reduce the count distance by 1, and then this here is not executed again. We just go back to the condition, is count distance greater than 0? Yes, it would be 3 now. So we again check even or odd, print this, go back, decrease by 1, check again. Now 2 is still greater. We print this and decrease again until count distance here decreases to 0. And then it's not bigger than 0 and we stop. So the for loop then exits here.
And one small thing that maybe we could also mention real quick is you cannot use count distance outside of the scope of this. Yeah. Because basically, did they talk about scoping already in the lecture? Scope of variables?
I'm not sure.
Okay. So basically, all you need to know for now is that a variable lives or can be used, or we also call it lives in a certain scope, so in a certain part of the program, you could say. And for the helper variable that you create with the for loop, this count distance really only exists in here. If we do something out here, I don't know, count distance ++ or something, we will also be told by our environment, oh, identify count distance is undefined. Outside, we do not know what this is.
Yeah. If you want to practice a bit, I just came up with one more practice idea that you could do. This code, you'll have it in the slides afterwards. Take this for loop and change the logic. So here we are counting down. We are starting with distance 4 and reducing it in each iteration until it's bigger than 0. Change this for loop at home so that it looks something like this. And then of course you need something else here because this is not correct now anymore. So try starting from 0 and counting upwards toward the distance and stopping when you reach the distance. Try changing the for loop so you go in the other direction. So instead of counting down, count upwards. If you manage to do this without just trial and error and really thinking about it and then implementing it, then I think you understood how these for loops work. Okay. I do not think there were any relevant questions for the for loops. You all, of course, have the complete code, everything we did right now on the slides. You'll get them afterwards. And And yeah, so what did we learn today? What did you recap today? We did something with data types, operators, which also involved casts. We did compiler warnings and errors, how to interpret them, how to fix them. We did some debugging, although that was a bit, we had some issues, but I hope it will work for you. And then we saw structs, conditions, and loops. If you couldn't follow everything we said, then just watch the stream again, go through the slides again, try the code we coded on our own. Maybe do not look at the code we coded, just try to re-implement the program we did today on your own without looking at the code. Maybe this could also help you understand everything we did.
And because it came up in the chat, the slides will be uploaded. So in the Teach Center. You will find them on the course website.
Yeah.
They won't be on the Teach Center directly.
If you go to the Teach Center course website, and then once it loaded, scroll down to practicals, and here you already see the slides. So this could be like this, and click on these slides. You can already find them from last week. And go through them. So they look something like this, and you can read through them. Okay. Are there any pressing questions in the chat? I think we answered most of them. Everything about the assignment will be answered in the intro video. Some question about the style guide, but the style guide, if you can understand why it is like that, just accept it for now.
Think of it this way: if you ever work in a company, there will also be some kind of code regulations there. They may be very strict, they may not be very strict, it really depends. But if someone asks you to write in a certain style, it's an important skill that you're able to do that and that you're able to stick to those guidelines. It may seem like a drag now, but basically this is one of the only courses where you're forced to do this in the first place in your entire study program. So please just stick to it once, so you've done it, you've seen how it works, and
So the intro video for the assignment will not be a stream. We'll just release as a video. We'll write an announcement on Discord with a link to the video. And if I'm not mistaken, next time we are in the Hörsaal P1, so the big one. I think next time.
Yeah, and that won't be streamed, that will only be recorded, right?
But it will be recorded, so we can always watch it afterwards. But I hope that many of you come also to the lectures in person. Okay, so if there are no more questions, we'll have a short break now, and the lecture should start at 17. Okay, bye.
Bye.